out of, and they're connected. It doesn't look like they're connected, but they're connected underneath here. Okay, so they're really the same chamber. So there's one of these pellets is over here, but it's really connected over here, and one of them is sitting over here. So now, actually, let me take that out for a second. So now what I did is, here's the solution. What I did is I put the glass electrode in there, and now I have the wire in there, and then there's solution, right, in the glass electrode. So these, which is this bath, so if I want to redraw this just so that it's a little bit simpler, what I've got is I've got the solution, I've got the electrode, and then I've got my ground here, which is like that, okay? So what's going to happen is I'm going to take this and I'm going to stick it in the oocyte. And the oocyte, right, it has a potential that should be negative on the inside, right? So in order to get the correct potential, I want to start making this one and this one exactly the same. So I want to zero this so that it's the same as that. So the way you do that on this instrument is if you look over here, so this I think is what happens when you, I think the solution level goes down when you turn it off. So we can turn it back on just so the solution level will go back up. And you can have a look at this in a second. So now it's in solution, and you'll notice right now, and so what it's going to read is it's going to tell you the voltage on the electrode in these meters. So this meter tells you the electrode, the voltage on electrode on the right, and it actually has an R here, and this one tells you on the left. I believe that the one on the right is actually number 1. We'll have to check that. And yeah, the one on the right is number 1, and the one on the left is number 2. So I really should write R1L2. That might make it easier. So this says that there's 5 millivolts between that wire and the ground wire. So in order to zero it, it's very simple. It's electrode 1. You just hit this 0 V1. And you'll watch that will now become 0. And you guys are going to do the same with the other electrode in a moment. All right, so now, and you see it just changed. It just changed to -1. That -1 is pretty insignificant for what we're doing, but we always zero it. So when we're ready to do the experiment, I would even zero that -1. So that's the first step. The second step is to measure the resistance, and you hit R1, and it will tell you the resistance, which is 1.1 or 1.2 mega ohms, maybe even 1.3 mega ohms. That kind of variability is probably not too bad. It's nice when it's really stable, but this is pretty good. So you want a value that's between, say, 0.5 and 5 mega ohms. And we'll say more about that. We'd be a little bit more careful about that. For now, for our experiments, I think we're good if that's what you get. So, and the truth is, if it's a little bit below 0.5, it's probably okay. So we can sometimes get it to work with 0.2, and for now, we're not going to worry too much about that. So, so again, this and so if I went to 0 V1, it would go back to 0. So this is telling you the voltage on V1, which is on the right, and this is going to tell you the voltage on V2, which is on the left. And then when you hit the resistance, R1, it will give it up here. And when you hit R2 to get the resistance on R2, which is what you're going to do, it also happens to give it up there. They give it at the top meter. So the top meter gives you the resistance readings, and then each of the separate meters are used to measure the voltages. So what you want to do now, I'm going to turn this off. I actually can pull this out.
Is the resistance based off of the electrode?
Well, so the resistance then, that's a good question. The resistance, I'm going to turn this off. The resistance is based off of... So is that Vincent?
Yes.
So this is Vincent is the master student, and these are the osteopathic students. So the resistance is based on. I'm going to go over. I'm just trying to find a spot to draw on it. It's based on something to do with the resistance. So there's all solution in here, and there's a wire here, and there's a wire here. It's based on the resistance between that point there and that point there. And whatever determines that resistance. So there's resistance in the solution, but it's pretty minimal. It's a pretty good conductor. And there is resistance here, as you imagine, as the tip. changes. And so if you had a really, really pointy thing like that, that would have a high resistance. Also, if you had something that looked like this, that was pointy and looked like that, it would have a different resistance than something that looked like that. So the resistance is a function of the shape and diameter of the electrode.
What about like the calcium one that you put on, like the bleach, the calcium ion?
Oh, so no, I think that will not impact the resistance of this system. That's much, much lower resistance than anything else. Even the solution resistance is minimal compared to all this. So if you put Vincent, if you put both of the oocytes in dishes, I can show you which one. I meant to mark which one I thought was better, but if you put them both in dishes, I can show you which batch I thought was better.
Right. I wanted to ask you about the vial for the RNA. Which one should I be getting today?
Same one we made new stuff, right? L20. Is that with you? Oh, it was with these guys. I did it. We made another one. So if you look on the database, the most recent one, you'll see the one I did last week with these guys. That's the tube you want to use. Did you have to leave? No.
Yeah, I don't know what to do.
So, yes, 12:47, so you don't have to go. All right. So what you want to do then is, I'm just going to turn this light off. What you guys want to do is you want to pull an electrode, because I think we're going to just throw this one out. All the electrodes that we don't use go in here. That pull seems fine, so you can just redo it. Now the thing is, the resistance may change. It's not the best system, or at least I should say, we don't have it optimally set up. So I don't know how good that filament is. I'm suspicious about that filament for a variety of reasons. So what you want to do is pull another 2 electrodes and take one of them, fill it up, and put it in there, and then we'll check the resistance.
All right.
You want to do it?
So like I have like a kind of like a phone palm at this time when you're explaining this. So just for Ryan, just real quick, what is this and this?
These are the pellets.
Mm-hmm.
These are the pellets that are in the bath there. The
Okay.
pellets are, I'm going to kind of get in front of you, the pellets are these things right here that are going into the chamber, and you can see them. If you look, you can see right there. I can actually turn the light on. You can see right there the
I see. The little black thing.
and that little black thing right there.
I see.
And if I can make another drawing of that if you'd like, make it a little bit clearer. I can actually get a piece of paper and draw it and label it for you, and then you guys can have that.
Thought you were.
We figured it was either that or you were desperate to go to your.
I want to stay. I don't know.
Yeah, your
Yeah.
guys' schedules are funny. I mean, they're not. It's not fully obvious when you look online exactly what you guys are doing. And somebody emailed, I think Ryan emailed about that OSCE, about whether it's an all-day thing. I suspect the answer is no.
No, it's like-
but I don't know the
Yeah.
details. I think you guys have very short times, which is why I think why I picked
Yeah.
that day.
I think Strebel said he'll email out the time like this week or next week.
So you guys can let me know and we can readjust. So,